Welcome to SGITMYSTR, or your go-to IT technology guide. Like, share, comment, and subscribe for more powerful tech updates.
Welcome back to the channel. Today, we're taking the plunge into the deep end with Kubernetes, moving beyond the basics to master container orchestration like a true professional. This high-level technical guide is the ultimate deep dive you've been asking for. We're going to dissect Kubernetes, focusing on advanced concepts critical for large-scale professional deployments. In our previous series, we covered the foundational aspects of containerization and orchestration. You now understand what containers are and why Kubernetes is the industry standard for managing them. But to truly manage production-grade applications, you need to understand the gears turning beneath the hood, the advanced architecture, resource governance, and specialized networking that separates basic usage from professional mastery. Let's start by revisiting the Kubernetes architecture, but this time with a focus on the advanced interactions between the control plane and the worker node. The control plane is the brain of your cluster. We're talking about etcd for consistent state storage, the API server as the front-end interface, and the scheduler, which decides where your pods actually run based on complex rules. On the worker nodes, the kubelet communicates with the control plane and manages the pods and containers. Kuberproxy maintains network rules, and the container runtime, often Docker or containered, pulls and executes your containers. Now let's move into resource management. In production, inefficient resource allocation means wasted money and unstable applications. It's time to manage resources like a pro. Defining resource requests and limits is crucial. Requests guarantee minimum resources, while limits prevent runaway containers. This directly impacts your pod's quality of service, dictating how Kubernetes handles potential resource contention. To enforce organizational resource policies across your clusters, you must implement limit ranges to set default resource limits for pods and resource quotas to ensure namespaces don't exceed their allocated compute and storage capacity. Networking in Kubernetes is often where complexity peaks. We're talking about the communication fabric that allows your microservices to talk to each other reliably and securely. We'll delve into the Container Network Interface, or CNI, and how it enables network communication. Crucially, we'll cover network policies, which act as firewalls, defining exactly which pods can communicate with others. For advanced features like traffic routing, observability, and mutual TLS encryption, we introduce the service mesh, such as Istio. This layer abstracts complex networking logic away from your application code, providing enormous operational value. Containers are stateless by nature, but your applications need persistent data. Mastering Kubernetes storage is non-negotiable for stateful applications. We must clearly distinguish between persistent volumes, which represent the actual storage resources, and storage classes, which define the quote type of storage, enabling flexibility and portability across environments. Dynamic provisioning allows Kubernetes to automatically create persistent volumes when a claim is made. Furthermore, we'll look at volume snapshots for reliable data backups and recovery. Security cannot be an afterthought. Protecting your cluster and your data requires a professional, multi-layered approach. Role-based access control, or RBAC, is the foundation of Kubernetes security. It ensures that users and services only have the permissions they absolutely need, the principle of least privilege. Finally, we'll cover security contexts to define privilege and access control settings for pods, and the critical pod security standards, which establish baseline security requirements for all pods in your cluster. You've navigated the deep dive into professional Kubernetes management. You now have the knowledge to move beyond basic deployments and truly govern your containerized applications. Remember, prioritize resource governance with requests and limits, secure communications with network policies and service mesh, and implement robust security controls with RBAC and pod security standards. What topic should we deep dive into next? Let me know in the comments below, and don't forget to like and subscribe for more professional technical guides.